Welcome to this talk on adding passwordless authentication into OpenIddict using rock-solid knowledge's FIDO component. So in this talk, we'll add FIDO into OpenIddict, and we'll do that by using the rock-solid knowledge FIDO component. Once we've done that, we'll use that component to provide passwordless authentication via OpenIddict. So to do that, we're going to start with the OpenIddict Veloozia samples. We'll then add in the FIDO support using rock-solid knowledge's FIDO component, and then we'll change the flow. So rather than using a standard authentication mechanism, i.e. username and password, we'll use passwordless authentication. Okay, let's dive in. To create this example, I'm going to use some sample code from the OpenIddict website, and I'm going to use a project of theirs called Veloozia. And that project has a server and a client. So to set those up, the first thing I need to do is to create a solution. So for that, I can do .NET new sln from the command line. And that will create me a solution file called passwordless.sln. It just takes the name of the current directory. I can get the OpenIddict samples from GitHub at this URL. And if I look in the samples directory here, the ones I'm going to use are these Veloozia samples. So I can just copy these onto my computer. So I've copied those two samples into this passwordless directory. And if I look inside here, we can see we have this veloozia.client and veloozia.server. Now, before I can use these, I have to edit their project files. So the veloozia.client CS_proj file and the veloozia.server CS_proj file. So if I open these CS_proj files inside code, for example, we can see I need to set the target framework and also the versions for the packages that we are using. So for the target framework, we're going to use .NET 9. So we set this to .NET 9.0, and then I can add the version to each of these package references. And the version at the time of recording is 9.06 for the entity framework libraries. It's 6.4.0 for the OpenIddict libraries, and it's 3.14 for the Quartz extension library. And we can then do the same thing inside the server project. Again, we'll set the framework to be .NET 9.0 and similarly set the versions for the packages used by the server. So with that in place, I can open up the solution inside my IDE. I'm using Rider, but obviously this will work equally as well inside Visual Studio. Inside here, I can then add these existing projects. So I can add the Veloozia client project, and I can add the Veloozia server project. Now notice when we do that, there are some issues highlighted in red here. And this is due to the way the projects are structured on GitHub. So when I create these projects, I have to fix up these issues. And they're simple things like certain libraries aren't included. So I'll go through and fix all of those now. So with that in place, I just want to show you one other thing. So inside my server, if I look inside the startup code, this uses SQLite as its database, and it generates a database file for me in a temp location. And during development, I need to know where that database file is going to be and what it's going to be called. So I'm going to grab this text here and copy it into a variable called dbName. I'm going to use dbName when I call use SQLite, and I'm also going to print out that name. And this is purely for debug purposes. As I said, I just want to know where that file is going to be. I'm also going to move this definition of dbName out of the configure services call and into the class itself. And I'm doing that as we'll need this name a little later on in the project. So if I run my server, we can see in the output window that my SQLite database is put into this var folders td some random string /t and then OpenIddict-veloozia-server.SQLite3. And if I look inside this file finder, we can see that file here. So that's the one that's being used by this server for this demo. So that's nearly all the housekeeping done. I just want to add a couple more things. We are going to test out authorization. So for that, we need an endpoint that's protected. So I'm going to add that endpoint into my client application. In fact, I'm going to add two endpoints, one that's protected and one to allow the user to register for passwordless authentication. and that endpoint won't be protected. So I'll add both of those endpoints into the home index CS HTML page, and I'll do it at the bottom. So below this div here, we just add these two hrefs. One that'll point at home privacy, and one that points at the URL, and this will be the URL that starts our device registration, and we'll talk about all that in a moment. So as well as adding this link to this privacy endpoint, I also need to add the endpoint itself. So in the home controller, again at the end, I'll add the privacy endpoint, and that is marked with the authorize attribute. And then finally for this, we need to add in the view for the endpoint. So back in the views inside home, I'll create this file called privacy.cshtml, and that will just display after we've been authenticated. Now on top of this, I want to add two more things. One is a CSS file. I'll put that in www style sheets. And in that, all I'm doing is setting a font size on our anchor tags so that we can see this text more clearly as part of this demo. And then while we're here, I also want to add a JavaScript file into my server. So again in www, but this time in the JS folder, I'm going to add a file called fido.js. I'm not going to look at this file now, but we will cover this file in some detail through the rest of this talk. If you are following along with the code and you want access to the file, it's in the GitHub repository for this talk, and I give the URL for that repository at the end of this talk. So with all that in place, we are now good to go. We can now start adding code that we'll use to register our FIDO device and to use that FIDO device to do passwordless authentication. So adding passwordless authentication is essentially a two-step process. We have to add a mechanism that allows our users to register and say that they want to use passwordless authentication, and then we have to add a mechanism that allows users to use passwordless authentication. And we will do this in our server project. Now, to make that work much easier, we'll use Rock Solid Knowledge's FIDO component. So the first thing I want to do is to add the Rock Solid Knowledge FIDO packages. And we can do this using NuGet. So I do a search for rsk.fido. You'll see there are two packages that I can add. There's the base FIDO package, and we'll add this into the server. And there's also the entity framework package, and we'll also add that to the server. Now, initially, we'll just use the base FIDO package. But at the end of this course, we'll see how to hook this into entity framework as well. With those packages installed, we can now add the FIDO component into the application. So in my server code, inside startup.cs, right at the end of the configure services file, I can call services.addFIDO. So this function accepts a lambda, and that lambda takes some options, and I have to set those options. So we need to set what's known as the relying party ID. Now, the relying party is the name of the server that's going to process the requests. In our case, that's going to be localhosts. Now, as well as that, I need to add 2 bits of licensing information. To use this component, we have to get a license. And when we get the license, we'll get the name of the licensee and we'll get a license key. Now we can get our license from OpenIddictComponents.com. If I go to this website and go to products and look for fido.net, here we can either buy a license or we can get a demo license. So if you enter your name and your email address, Rock Solid Knowledge will send you a demo license. Now I've done this already. So to use this license, I'm going to add a file to my project called license key. And into this class, I'm going to add 2 values. I have a demo license, so the licensee will be demo, and then this key is the key I received when I registered for a demo license. And this is valid for a month. So back in startup.cs, I can say o.licensee equals license key.licensee, and then o.license key equals license key.key. And then when I've done that, I have to tell the component where to store its data. Now, initially for this, we'll use the in-memory store, only because for now, this is easier to set up. I'll add the entity framework store towards the end of this video. With those in place, I now need to add the code that lets our user register. And to do that, in my server, I'm going to add a new controller. And we'll create a controller called FIDO controller. So in this controller, we don't need the index method. So we can get rid of that. Now, I've said that when we use FIDO, we have to do two things. We have to register our user and our device, and then we have to authenticate using that device. The first part of registration is to get the user's name and the device name. And we have to prompt the user for that information. And we can do that by creating a view. So to do that, we're going to create an endpoint on this controller called start registration. So this will be a public iActionResult function called start registration. And this will take a string, and that string will be the return URL. And this allows me to redirect back to wherever I came from to start this registration process. In here, I'm going to return a view, and that view will display a UI to the user to allow them to enter their username and the device name. So into this view, I need to pass a model. So let me create that model first of all. So in view models, I want another directory called FIDO. And inside here, I'm going to add a view called start registration. And this will have two fields that the user can enter. It will have the device name field and the email field. And we'll also pass our return URL into this model as well. Back in the controller, I can say start registration model equals new. And then into this, I need to pass the return URL. So I can say return URL equals return URL. And we'll gather the device name and the email from the user interface. I then want to pass that model into my view. Inside my views directory, again, we'll create another directory called FIDO. And into that, I'll add this user interface. So we'll add a file called startregistration.cshtml. Now this file asks for the email and for the device name. Once we have that information, we then send a post request to another endpoint called register. And that's where we kick off the registration process. So back inside my FIDO controller, I'm going to add another function called register. This is an async function, and it returns a task of iActionResult. And notice this also takes a reference to this registration model. The first thing I want to do in here is to check that that model is valid. And if it's not, we'll just go around this loop again. So we'll go back to the original start registration call. If this model is valid, then it will contain an email address. And the first thing I want to do in that case is to check that our user doesn't already exist. Now to do that, I need access to the user manager. So at the top of my controller, I'm going to add a constructor. Into that constructor, I'm going to pass a user manager. And that user manager will be of type application user, which is our user type in this application. And we'll call it user manager and assign it to a field called _user manager. Back in the register function, I want to say something like this. If await _user manager dot find by email async is not equal to null, i.e. we found a user, then I'm going to return a bad request. I'll add a message to that return, which just says a user with that email address already exists. Now, if the user doesn't exist, we want to kick off the registration process. And to do that, we need access to the FIDO component. So again, back in my constructor, I'm going to add another parameter, and this is going to be of type iFIDO authentication. And I'll just call this FIDO. And again, we'll assign this to a field, in this case called _FIDO. Back in the register function, I can now use this component to kick off the registration process. Now it's going to be a two-stage process. We start the process at the server, and I then return to the browser. The browser then interacts with the user's device. And if that interaction is successful, we can then complete the registration. So to kick off this registration at the server, I take my component and I call initiate registration. To initiate registration, we pass the email address and we pass the device name. Now, this is an async call, so I want to await on it, and then it returns to me something of type FIDO registration challenge. Once we have this challenge, we're going to send it back to the browser, and the browser will use the details in the challenge to interact with the user. Now, as well as sending the challenge back to the browser, I also want to send the return URL back to the browser. So to do that, I'm going to create a new model. So back inside View Models, inside FIDO, I'll add a view model called Register. And this view model holds two fields. It holds the return URL, and it also holds the challenge. But notice the type of the challenge we're sending back here is a base64 FIDO registration challenge. So we take the challenge that's been returned from the initiate registration call, we base64 encode it, and then we send that back to the browser. So to do that, we have code something like this. I want to say var register equals new register. Then to this, I'm going to pass the return URL, and that will be equal to my incoming model return URL. And then I want to pass this base64 challenge. So this has a field called challenge, and we set that equal to challenge dot to base64 DTO. And that will create me a base64 version of this FIDO registration challenge. I'm then going to return this to the browser via a view. So I create the view and pass the view this register model. So let's go and take a look at that view. So in my view section, in the FIDO directory, I'm going to add a view called register.cshtml. So the first thing to say here is that we pass in a reference to this register object. And from that, we pull out the challenge and we pull out the return URL. Notice I'm also including this fido.js file. And that's the JS file I added into this project a few minutes ago. And we'll see what that does in a moment. We then have a script block, and the script block calls a function called register, which is in this fido.js file. Into that function, it passes in the base64 challenge, it passes in the relying party ID, which should match the one we set earlier, and it then passes in these two values, the user handle and the user ID, and it uses these to identify the user. We also pass in two endpoints. The first one is the endpoint we use to complete the registration. Remember here, if I look back in the controller, we are initiating the registration. After this has been initiated, we then need to complete it. Once the registration has been completed, we then need to return to some page that our user can interact with, and that's the return URL. So let's take a look at this register function. So if I go into my www.root, JS, and fido.js, this is the register function. If I scroll down here, the key part of this is this call to navigator.credentials.create. Into this, I'm going to pass in the information we get from the initiate registration, along with the user details. So into here, for example, we pass the challenge, we pass the relying party, and we pass in the user. When we call navigator.credentials.create, that's going to interact via the browser with your FIDO device, which could be a hardware device, or it could be a password manager, or it could be something like Face ID on Apple, or a thumbprint maybe on Android. If this call succeeds, we create some credentials. And those credentials we're going to pass back to the server in an AJAX call. And we pass them back to this callback URL. That callback URL is the FIDO complete registration URL. If that AJAX call succeeds, we then redirect back to the return URL. And that's this return URL value that we're passing into this view. If anything fails, we're going to print an error onto the console window. Okay, so let's write this complete registration endpoint. So back in my FIDO controller, I'm going to add a function called complete registration. Now remember, complete registration is called from our JavaScript file and is passed up these encoded credentials. The type of those credentials is this base64 FIDO registration response. Again, this is a type that comes from the FIDO component. The first thing I'm going to do is to take our FIDO component and call complete registration on it. Into this, I pass the registration response, but I have to decode it. And there's a helper function here called toFidoResponse that turns the base64 FIDO registration response into a FIDO registration response. The call to complete registration is async, so I await on it, and it returns me an iFIDO registration result. And we can then check that result. So I want to say something like this. If result.isError, I'm just going to return a bad request. Something has gone wrong, and I let the browser handle that. You may want to do something different in your code when this happens. Now, if this registration has succeeded, I need to create a user and add it into my user store. So to do that, I'm going to create an instance of my application user. I have to set a username and an email. And these will be the email values I set when I initiated the registration. Once I have that, I can call the user manager.createAsync. And I pass in this user object. Again, this is an async call, so I need to await on it. And this will return me an identity result. So I can say identity result equals, and then await on this create async call. If that call succeeds, I'm going to return OK back to the browser. And if it fails, I'm going to return a bad request back to the browser with some error information. So if this call succeeds, if I look inside my JavaScript, then we get to this line. We've done the AJAX request, we've sent the request to the callback, which is complete registration. That call has succeeded, so we hit this success callback. Inside the success callback, I'm setting window.location.href to be whatever return URL I set right at the start of this process. So now we've got this far, we should be able to run this code and register a device. So let me run the server first of all, and then let me run the client. So they are both running, and the client looks like this. And we have this register endpoint that we added earlier. If I click on the endpoint, that takes me to the first view. Inside here, I need to enter my email address. So let's enter kevin@rocksolidknowledge.com. I need to enter my device name. Now I'm using a password manager, and the one I'm using is Dashlane. So I just enter Dashlane as the device name here. I click on register. This will initiate the registration. When I do that, we send a request from the server back to the browser, and the browser is going to interact with whatever FIDO device we have. So I click on register, and Dashlane pops up a message asking me to create a new passkey. I click on confirm. We've created the passkey, and we've redirected back to our home page via the redirect URL. And then from here, I can now go and log in. Now at the moment, that process isn't in place, and that's what we'll do next. So the login process is very similar to the registration process. Again, we'll have three endpoints. One to get the user's name that we can use to find the user in our system, one to start the login, and one to complete the login. So let's start with the user interface to get the user's name. So again, into FIDO controller, I'll add an endpoint, this time called start login. That has a model called start login, which we can add into our view models. And that looks like this. It just lets us get the email, and again, we'll set a return URL. And obviously, we also need the UI for this. So inside our views, we add the start login CSHTML page. And notice into this, we just pass an email address. We don't need the device name now. We're assuming that device is available to do the login. Back in the controller, as before, when the user types in their email address into this page, they'll click on the submit button, and that will send a request to the start login endpoint. And again, it's going to send a post request. So back in the controller, I need another start login function. This time, one that will accept an HTTP post and also takes a reference to our start login model. Again, in here, we check that the model state is valid. And if it's not, again, we go around the loop. So we go back to our original start login call, passing down the model. If the model state is valid, again, we want to use the user manager and see if our user exists. But this time we expect the user to exist. So if they don't, we return bad request. So this is the opposite of what we did in the registration. In the registration, if the user existed, we return a bad request. In login, if the user doesn't exist, we return a bad request. Now, if the user does exist, we need to initiate authentication. And again, we do that through the FIDO component. So I call fido.initiate authentication. Into this, I pass the email address. Again, this is an async call, so I need to await on it. And again, this returns a challenge. And this challenge, we're going to send back to the browser. Now, this challenge is of type FIDO authentication challenge. So when we did the registration, we had a FIDO registration challenge. Now we're doing the authentication, we have a FIDO authentication challenge. And in the same way that we base64 encoded the registration challenge, we can also base64 encode the authentication challenge. Now, once I've done that, I need to send some information from this challenge back to the browser. So to do that, I'm going to create a model called login. So inside view models, I create this login model. And this has these fields. It has this relying party ID. It has a reference to the challenge. It has a return URL, a user ID, and some keys. And these keys are values we will use to check that this challenge is correct. So in the FIDO controller, I want to say login model equals new, and then pass the various values I need into this. So we need the user ID, and we can get that from the challenge. We need the challenge itself. So I'm going to pass down the entire challenge. We need the relying party ID. And again, we can get that from the base64 challenge. We need the keys. Again, we can get those from the challenge. And we need the return URL. And this time, that's in the model. Once I've created my model, I need to send that back to the browser. And we do that by returning a view. The view will be called login, and we'll pass this login model into this view. So let's create that view. So in my views directory inside FIDO, I add a view called login.cshtml. And again, this is very similar to the view that we had for registration. We include our JS file. We call complete login. We pass it the base64 challenge. We pass it the relying party ID. We pass it the keys. And we pass it two URLs. The first URL, fido/fido complete login, is used to complete the login. Again, just like complete registration. So we initiate authentication and then we complete authentication. If we complete authentication successfully, we then want to return to whatever our return URL is. If I look at complete login, again, it's very similar to our register call. And again, the key part of this happens here. So I call navigator.credentials.get, and I pass in the information from our challenge, including the challenge and the relying party ID. That call interacts with the FIDO device, and if it succeeds, we get back this result. I then use AJAX to call back into the server, and I pass back up this encoded result. And I'm calling back into this callback URL. And the callback URL is /fido/fido complete login. So let's add that now. So in the controller, I want a function called FIDO complete login. Again, it's an async function, and it takes a base64 FIDO authentication response. First thing I'm going to do in here is call fido.complete authentication. And to this, I'm going to pass the authentication response, but not the base64 version, but an actual instance of this response object that I get by calling to FIDO response on the base64 version of this. If we can't complete authentication, then I return a bad request. If authentication succeeds, then I want to find the user that we registered above in our complete registration. If that call returns null, then again, I'm going to return a bad request. But if that call succeeds, I want to sign in the user. And to do that, I need access to the sign-in manager. So as well as the user manager and the iFIDO authentication, I want a sign-in manager. again of type application user, and we'll call this sign-in manager, and we'll assign it to a member of this class. So if we have a user, we're going to await on underscore sign-in manager dot sign-in async. We pass this to the user and a flag saying this is not a persistent sign-in. And if everything is okay, we're going to return OK back to the browser. Now remember, if I return OK back to the browser, we hit this success function here, and we're going to set our href to be some value I can go back to. Okay, so we're almost there. So let me run the server, and let me run the client. Now at the moment, we've registered our user, and I want to use passwordless authentication to log in. We have this privacy linked, which we know is marked with our authorized attribute. So we have to authenticate before we can hit this link. So if I click on this link, it takes me off to the original login page. And this is not what I want. I don't want to do a standard username password login here. I want to use the passwordless login. So I need to replace this page. So to do that, back inside my code, if I go into my startup.cs, I want to configure my startup to use the passwordless login endpoint when we want to authenticate. So to do that, I'm going to say services.configure application cookie. This takes a lambda. We pass some options into this lambda. And on these options, I want to set the login path. And I'm going to set the login path to be /fido/start login. Now, before we see if this works, I need to tidy up slightly. Now, at the moment, we are storing our FIDO information in an in-memory store and our user information in a database. And these two don't match currently. Because as soon as I restart this service, the in-memory store gets recreated. So what I'm going to do is to delete the database and then restart the application. The database will then be recreated in an empty state, and we'll have an in-memory store in an empty state. And that's why I wanted to print out the name of the location where we've created this database. So if we look in that location, we'll find these OpenIddict Velusia server files. I'm just going to delete those. I'm then going to kill both the client and the server. I can restart the server, and that will recreate the database for me. I can start the client, and then we can run through the process of doing registration and authentication. So let's start with registration. So we've seen this before. I can enter my email address, my device name, click on register. Dashlane kicks in, I confirm the registration. If I now click on privacy, it takes me to the passwordless login page. In here, I can type in my email address, click on login. It asks me to interact with my authenticator. Click on confirm. We log in. It's trying to take me to the privacy page, but I have to grant access. I say yes, and I'm now on the privacy page. If I go back to the index page, we also list out the claims that we have. So we can see that we are properly authenticated here. And while this is good, while it all works, we still have an issue. We're still using the in-memory store. So let's go and fix that now. So to use the database store rather than the in-memory store, I need to do a couple of things. Here, rather than calling add in-memory key store, we need to call add entity framework store. Again, this is past a lambda into which we can pass some options. And into these options, we need to tell it what database to use. So we can say options.use SQLite. To this, we have to pass the file name. And that's the name that I set right at the start of this talk. So that's DB name. And then I'm also going to configure this to set up the migrations. So here we have another lambda. So I can say DB opt goes to, and then inside this lambda, we say dbopt.migration assembly to tell it which assembly the migrations live in. And this will be type of, and we can just use this class here. So type of startup.assembly.fullname. So we're now set to use the entity framework store. But now I have to generate and use the migrations. Now I'm going to create and update these migrations from my terminal window. To that, you have to make sure that the .NET EF tools are installed. So again, we can run .NET tool install -G for global and then .NET-EF. I can run this, but the tools are already installed on my system. Although notice it's updated them for me from 9.05 to 9.06. That's a good thing. Once we have the tools installed, I can run .NET-EF migrations add to add a migration. I'm going to call the migration FIDO, and the DB context for the FIDO component is FIDO DB context. So if I run this, that will build the application and create the migrations for me. Once I have that, I can then run .NET-EF database update, again using the same DB context, and that will apply those migrations to my database. And I can see that. So back inside Rider, if I look inside the database tool window, I can drag my SQLite database into this window, say OK, look inside here, look inside main, and we can see that within this database, as well as having the ASP.NET tables and the OpenIddict tables, we have our FIDO keys table. And that's the table used by our component. So again, just to show that this still works, if I run the server and I run the client, if I go to the browser, we have to go through the process again, as everything is now held in the database. So I register. Again, we can use Kevin at rocksolidknowledge.com. Device can be Dashlane. Click on register. Dashlane pops up, asks me to confirm the new passkey. Click on confirm. We go back to our homepage. Click on privacy. Again, we have to enter my username. So Kevin at rocksolidknowledge.com. Click on login. Again, Dashlane pops up. Click on confirm. And we go to the privacy page after we grant access. So that all still works. Now, if I go back to Rider and take my server and restart it, go back to the browser, and then in here, before I do anything else, I'm going to clear all of my cookies. So I'm now essentially logged out. If I go back to the home page, I've refreshed the page, we're still logged out. But now I shouldn't need to register. I've already registered. So if I click on privacy, it takes me to the passwordless login page. I can say Kevin at rocksolidknowledge.com, click on login, use the authenticator, and sure enough, we logged in. And we're at the privacy page. So we've seen how to add registration, we've seen how to add authentication, and we can now do passwordless authentication with a FIDO device and using Rock Solid Knowledge's FIDO component. Thanks for watching. The code for this video is on github.com. It's at https://github.com/kevinrjones/OpenIddict-passwordless.